Next, let's walk through an example of how to test a null hypothesis when working with a sampling distribution of means. So you'll notice that this is set up with a very similar starting approach to what we had with the confidence interval. We're going to do a very similar thing to our approach for proportions. We're just going to change how we estimate the standard error, which model we get our p-value from. We're going to work with our same sample of 9 men with a mean height of 72 inches and a standard deviation of 6 inches. We want to run a test for a null hypothesis that the true mean height is 77 inches. So for some reason we believe that the true null mean height of all men is 77 inches. And we want to test whether our sample is likely to have occurred if that is the case. So again, we calculate our standard error. This is just like we did on the previous page. The sample standard deviation divided by the square root of n. 6 divided by the square root of 9, which is 3, gives us 2. Degrees of freedom are always 1 less than our sample for when we're working with means. So we take 9 minus 1, gives us a degrees of freedom of 8. Now we want to calculate something with the t distribution, but here we're going to do something a little bit different. Now we want to calculate a t statistic. So just like in the proportions we calculated a z statistic, we want to calculate how far off our sample is from our null hypothesis. So here we are going to take our observed value, 72 inches, minus our null hypothesis, 77 inches, divided by our standard error. You'll notice this looks almost identical to a z-score. That's because it is. The difference is that we're going to use the t distribution, and this has a slight difference because of how the standard error is calculated, which means we're going to call this a t statistic instead. So we take 72 minus 77 divided by 2 gives us negative 2.5. And now we want to find out how likely that is. So what is the probability of getting a t statistic with 8 degrees of freedom that is less than or equal to negative 2.5? So we're again going to go to StatCrunch. We're going to, instead of working with our values there, plug in our 8. Okay, now we want less than or equal to negative 2.5. I'm going to click Compute. So you'll notice that this comes up red in the outer tail on this side. If I had switched this to say greater than, the red would be over here in the middle. That's not what we want. We want to see the values that are more extreme than our calculated value. So here we get 0.018471101. So that's going to be our answer here. 0.185 is the rounding I'm going to use just to keep this all on the slide. Now this could be our p-value if we had an a priori reason to think that our sample was going to be smaller than 77 inches. So for example, if our mean height of 77 inches was for full-grown adults and we were measuring high school students, we might justify using a one-tailed t-test. Here, however, we want to use a two-tailed p, which just means we need to double our value because the t distribution is symmetric. We can see this by switching this to greater than and positive 2.5, and you'll note that we get the same exact value. This is important because if we don't have an a priori reason to have one direction or the other specified, we are just as likely to be wrong in either direction. So with our calculated p-value of 0.0369, this means that a mean of 72 inches or less, or 82 inches or more, is likely to occur about 3.7% of the time if the true mean is 77 inches. This seems like a rare occurrence, so we might reject our null hypothesis. That is to say, it is unlikely for us to have gotten a sample mean of 72 inches if the null hypothesis is true. So we say we think that the sample null, or excuse me, our null hypothesis in this case may be less likely to be true.